Hello, this is Professor Matt Katroulis of Rio Hondo College, and this is our first video lecture for Chapter 5 on the topic of chemical reactions. Before we begin, I would like to ask you to print out the set of notes that are provided for this chapter. I have provided them at a link right below the video. They're also likely available at the course website. And the reason for this is that this chapter tends to be fairly heavy in calculations, and there's a lot of problems, and rather than ask you to write out each problem by hand, I think it would be simpler for you to just print those problems out and fill them in as we go along. So let's take a look first of all at what do we mean by chemical reactions, since that's going to be the focus of this chapter. So the definition of this is when we talk about a chemical reaction, that is a process which takes one or more substances and it changes them into one or more different substances. If we go back to the definition of pure substances, we're talking about elements or compounds. So we could start with a compound and then form two elements from that, or we could do the opposite, react two elements to form a compound. But ultimately what we see is that there is a change in formulas when we have chemical reactions. So we document chemical reactions using chemical equations, which have some particular symbols which have a significant meaning for these processes. So the substances which we begin with are called the reactants in a chemical reaction, and those things that are formed in the reaction are called the products. So we write out a chemical equation by putting the formulas of the reactants on the left side. We put the formulas of the products on the right side, and then in between them we put an arrow to show that there has been a chemical change. And sometimes we use symbols or numerical values above or below the arrow to indicate the different reaction conditions. So here is an example of a very common reaction. We have hydrogen reacting with oxygen, and the arrow tells us that these are the reactants, what we started with, and H2O is the product, water. And of the symbols we're likely to encounter, there is of course the reaction arrow. We will sometimes see the letter delta used for heat, and then oftentimes we will use these symbols right after the formulas to tell us the state of matter, so if something is a solid or a liquid or a gas. So for example, we might put G and G after both of those to indicate that they are a gas. And water, when it's initially formed, is going to be a gas as well, so we could put a G there, or an L if we thought it was going to be a liquid. Now let's take a look at that equation in a little bit greater depth. So we're saying hydrogen is reacting with oxygen to make water. There's a very serious problem with the way that this reaction is written. If we look very carefully at each of the atoms in the formula, we'll see that on the left side of the equation we have two oxygen atoms. Oxygen is diatomic, it's always found in pairs of atoms. But in this formula, the oxygen is by itself. So that's a problem, because one of the most important rules in all of chemistry is the law of conservation of mass. And what it tells us is that you cannot create or destroy matter. In other words, that oxygen couldn't have just disappeared into nowhere. This is a vital part of chemistry. And in fact, if you remember nothing from chemistry in 20 years, the law of conservation of mass is probably the single most important statement to know. So we can't just document the chemical equation this way. We have to show that in fact we are ending with the same amount of oxygen that we started with. And so the technique we use to accommodate that is what we call balancing. And we balance to show that there are equal numbers of each type of atom on either side of the equation. And the process for balancing is to put coefficients, which are just simply numbers, in front of the chemical formulas, so to the left of the formulas. And those are going to multiply all of the atoms that are in the formulas to increase them. You are strictly forbidden from ever changing the subscripts that are already in place in a chemical formula. Why can't you do that? Well, if you change the subscripts, you're actually changing the chemicals to different types of chemicals. So, for example, if we go back to this reaction here, you might have suggested just putting a 2 there. And sure, that would give us a balanced equation, but it would be wrong, because it would be saying that hydrogen plus oxygen makes H2O2, which is peroxide, hydrogen peroxide. And that's not what's made. It's always water. So the only place that you can make changes are strictly to the left, right in front of the chemical formulas. So the way that we go through this is we first count the number of each type of atom on both sides of the reaction. You want to identify any elements that are somewhere by themselves in the formula. Those always want to be balanced last. That makes it much easier to balance those. If there's any elements which are always tied up with other elements in the formulas, you probably want to address those first. And then each equation has its own logic, and you just simply have to use trial and error to balance these equations. So the best technique for learning balancing equations simply is to practice, to do them over and over. And I'll provide a worksheet of several examples to let you do that. So here are 5 chemical equations, and we want to go ahead and practice balancing these. Remember, you may not change a single thing that is written here. The only thing that can change is numbers in front of each of these formulas. So let's go over to our notes sheet and work out each of these problems. So let's go ahead and find the correct coefficients for each of these values here. So we'll start off with some of the simpler ones, which are these two right here. So I have 1 magnesium on the left and 1 magnesium on the right. The way that we might start writing this is to do the following. Just kind of keep a little table here like a T. So on the left I have 1 magnesium, and on the right I have 1 magnesium. On the left I have 2 oxygen atoms. So notice I don't take any of these numbers with me for right now. I'm just counting them. 2 oxygens, and on the right side I have only 1 oxygen atom. So I'm not balanced in oxygen. So what I need to do is I need to increase this from 1 to 2. And I can't put a 2 here. Why? Not just because I said that you can't. It's because, remember, this is an ionic compound, and the charges must add up to 0. If I put a 2 here, the total charges of the oxygen would add up to -4, and magnesium would be +2. That doesn't work, so I can't put a number there. So to get 2 oxygens, I have to put a number in front. That's called a coefficient. What does this give me now? It gives me 2 magnesiums and 2 oxygens on the right. Well, now we're unbalanced in magnesium. But because magnesium appears by itself in the formula, that's easy to fix. We just need to put a 2 in front. And we are now balanced. Some people will write a 1 in front of chemicals where there's no symbol, but that 1 is optional. You don't ever need to put a 1. If there's no 1 in front, then it's understood to mean the number 1. Alright, let's try the next one, which is very similar. And after a while we stop using these T diagrams, but it's a good way when you're first learning. So on the left side we have 1 mercury and 1 oxygen. There's no number there, so that means we have 1 of each. So we have 1 mercury and 1 oxygen. On the right side, we have 1 mercury, but because oxygen is diatomic, we have 2 oxygens. So we're going to do pretty much the opposite of what we did up here. We saw that there were 2 oxygens on the on the right side, so we now need to put a 2 in front of this compound here, mercury 2 oxide, to balance that out. So when we do that, now what do we have? We have 2 mercuries and 2 oxygens on the left side. Well, now the mercuries aren't equal, but fixing mercury is very easy. We just put a 2 in front of the mercury. And now we are balanced. You may put a 1 in front of the oxygen if you wish, but it is not required. Now we're going to move on to one that's just a little bit more difficult. And the reason for that difficulty is there are now 3 elements in this chemical equation. So we have sodium, magnesium, and chloride ions. I'm going to still use a T diagram here. And after a while, we'll, as I said, start just doing that in our heads. So on the left side, I have 1 sodium, 1 magnesium, and 2 chlorine atoms. So I've got 1 sodium, 1 magnesium, and 2 chlorine atoms. But on the right side, I have 1 magnesium, 1 sodium, and 1 chlorine. Probably a better idea to write these in the same order here. So let me change that. So 1 sodium, 1 magnesium, and 1 chlorine. Now, I had recommended that whenever you have elements by themselves, you want to balance those last. So sodium appears by itself and magnesium appears by itself. Those will be the easiest ones to fix, because as we saw here, you just have to put a number in front of it, and it doesn't adjust any other elements in the process. So chlorine is what we want to balance first. So I've got 2 chlorines on the left, 1 chlorine on the right. So I'm going to simply put a 2 in front of sodium chloride. And that gives me 2 chlorines and 2 sodiums on the right, because it multiplies. Alright, so we're balanced right now in chlorine, we're balanced in magnesium, but sodium we are not. Sodium is easy to fix. We just put a 2 in front. And we now have a balanced equation. And again, if we wanted, we could write 1s in front of the magnesium chloride and the magnesium. Now we get quite a bit more complicated. There's several more elements in here. So let's take a look at this one. Well, first we have sodium. And there are 3 of them on the left. But we have P and 4 oxygens. Or is that what that is? If you remember, PO4 is the phosphate ion. And it's exactly the same on both sides. I strongly recommend that if this is the only phosphorus and this is the only phosphorus and the only oxygens are in that ion, it's much easier to balance this as an ion than it is as separate elements. So I'm just going to write PO4 here. And of course, it would have a 3- charge, but I don't need to worry about that for right now. So I'm going to leave the charge out. How many phosphates are there? There's only 1. And 1 barium and 2 chlorines. Okay, so on this side we have 3 bariums, 2 phosphate units, and 1 each of sodium and chlorine. So we are definitely not balanced just yet. There's nothing that cries out to be done last or first in this case. So my preference would be just to take care of the polyatomic ion first. So if I've got 2 phosphates here, let's make there be 2 phosphates here by putting a 2 in front. So that fixed phosphate, but it messed up sodium. Well, sodium wasn't balanced anyway. How many do I have now? We multiply. There are 2 sodium phosphates. Each sodium phosphate had 3 sodium ions in it. So therefore 2 times 3, there are 6 phosphates, 6 sodiums on the left side at this point. Let's just fix sodium. So to fix sodium chloride, I would need to put a 6 in front of that. And this now gives me 6 each of sodium and chlorine. So let's handle chlorine now. So if we've got 2 on the left and we have 6 on the right, we need to multiply this by 3, correct? We need to get 3 times 2 for those to be the same. So we have BaCl2, so we put a 3 there. And in so doing, that also is going to change barium. So I now have 3 bariums and 3 times 2, 6 chlorines. And if I go to then fix barium, you'll notice it's already balanced. So that took care of all of those at once. So this is the balanced formula. And again, we could put a 1 in front of barium phosphate if we wanted to. And then finally, this very important reaction for life. This is one of the key reactions keeping you alive. It is respiration. So this is glucose reacting with oxygen to form carbon dioxide and water. I'm not going to do a T diagram this time. Let's just try to keep this in our heads. So which element to do last? We have oxygen by itself here, so it'll be easiest if we put off oxygen to the end. Let's do carbon first then. So we've got 6 carbon. The only thing with carbon in it on this side is the CO2. So let's put a 6 in front of the CO2. And I've already decided I'll worry about oxygen last. Hydrogen. I have 12 hydrogens. So the only chemical with hydrogen in it is water. So to get to 12, I need 2 times 6. So now carbon is balanced, 6 carbons. Hydrogen is balanced, 12 hydrogens. And now the only thing we have to worry about is oxygen. It might be helpful actually to do a T diagram just for the oxygen at this point. So just for the oxygen, how many oxygens do we have here? On the right, we have 6 times 2 is 12. Plus, we have 6 times 1. 6 is 18. On the left side, I have oxygen in 2 different formulas. I've got 6 here, plus 2, which is 8. But I want to get to 18. Now, I don't want to put any numbers here, because if I put any numbers here, that will unbalance the carbon and the hydrogen. So we would like to leave this formula alone. So if we have 18 on the right, we want there to be 18 on the left. And so what we need to do is simply solve this equation. 6 plus what? Question mark there. Is 18. Well, that would be 6 plus 12. So we need 12 additional oxygens here. And if we've got an O2, to get this to 12, that would be 6 times 2. So 6 times 2 would be 12. So for a total of 6 plus 12 is 18. 6 times 2 is 12, plus 6 is 18. We have 18 oxygen atoms on both sides. And if we'd like, we could go ahead and put a 1 in front of glucose if need be. Let's do another problem. Here we have equations that are written out in words. And what I would like to do here is to balance each of these equations, but first we need to write them out as words. So let me zoom out a bit so we see everything. So what I would like you to do, first of all, is pause before doing each one of these and write the equation that we see in words. Then balance. So write this equation, please, from the words. Pause the video. And then when you've got it written, go ahead and unpause it. And actually, before you pause, you might want to make a note that methane has formula CH4. So again, go ahead and pause this video and write this as a balanced equation. Okay, I've assumed that you have paused this and attempted it on your own. So let's just write in the formulas first. So methane reacts with oxygen. So that would be CH4 plus O2, because oxygen is diatomic. Remember, the diatomic elements are hydrogen, nitrogen, oxygen, and then the halogens: fluorine, chlorine, bromine, and iodine. So whenever we see a word equation and we say something reacts with fluorine or chlorine, they have to be written like this in the formulas. Okay, and so it says we are producing carbon dioxide and water. Incidentally, the order does not matter. You could have written water plus carbon dioxide. That would be totally acceptable. So carbon dioxide plus water. And the word vapor is simply telling us it's a gas. Okay, so I am not allowed to change any of those formulas. So let me change colors here to recognize that I may not change anything in blue. All right, so what am I going to balance last? Oxygen. Oxygen appears by itself in the formula, so it's easiest to figure out later on. 1 carbon, 1 carbon. So carbon is balanced. 4 hydrogens, 2 hydrogens. So I need this to get to 4. So to do that, I'll put a 2 there. So 2 times 2 is 4. So now we are balanced in carbon and hydrogen. What about oxygen? Well, on the left side we have 2 oxygens here. On the right side we have 2 oxygens plus 2 times 1. So that's a total of 4 oxygens. So to get this to 4 is very simple. We just put a 2. I want to give another problem of this type for a moment. This is called a combustion reaction. We'll talk about those more in Lab 7. But I want to change this for a moment from methane to ethane, which is C2H6, and then keep everything else the same. So this is a totally new reaction. So it's a different problem. Oops, we don't want that 2 there. So I want to balance this one. So ethane is reacting. Well, the process would initially seem the same, wouldn't it? So we want to balance oxygen last. So I've got 2 carbons. So I'll put a 2 here. I've got 6 hydrogens. The only hydrogens over here are in the water. So to get 6, I need 2 times 3. And now carbon, we've got 2, hydrogen, we've got 6, and 6, it's balanced. And now, when we go to solve oxygen, we'll run into a problem. We have 2 times 2, or 4 oxygens. And over here we have 3 times 1. There are 7 oxygens on this side. Over here we have 2. And we know that there is no whole number times 2 that will give you 7. Well, we could do this and put 7 halves. It's something I want to avoid doing at this point. I'd rather just stick with whole numbers. But that is technically an acceptable answer for reasons that we'll see in a moment. So the way to go about this kind of a scenario, when you're stuck like this, so you have an odd number here and you can only get even numbers, is to simply double everything that you've already written or balanced. So we balanced carbons and hydrogens. Let's double everything. So that includes the ethane, the CO2, and the water. So let's just double all these. So the 2 and the 3. 2 times 2 is 4. This becomes 6. And this was a 1, so we're going to make it into a 2. So this should now make this much easier to balance. So the carbons are balanced. The hydrogens are balanced. Now, instead of having 7 oxygens on the right, we have 7 times 2, or 14. So that makes this much easier to balance, because to get 14, we simply need a 7 there. Finally, make sure that you check that none of these numbers has a greater common divisor than 1. So these are, I can't divide any of these by anything greater than 1 evenly. Okay, let's try another question here. Calcium reacts with iron 3 oxide, giving calcium oxide and iron metal. All right, take a moment to pause the video and write this equation. And when you're done, we'll come back and balance it. Okay, I'm assuming that you paused here. So we have calcium plus iron 3 oxide. It says calcium metal, which means just plain old calcium. Not calcium 2 or anything like that. That's just pure calcium. It's reacting with iron 3 oxide. You have to remember, iron 3 is Fe3 plus. Oxide, oxygen was in group 6A of the periodic table, and those are all 2 minus charges. So that means the formula of iron 3 oxide, we will just do our switching. So iron, we need 2 of them. And oxygen, we need 3 of. Remember, these charges don't appear in the final formula. This gives me calcium oxide and iron metal. So calcium, remember, was in group 2A. It only makes a 2 plus ion. Oxide is in group 6A. It only makes a 2 minus ion. So if we crisscross, we'd get Ca2O2. Since these are both divisible by 2, though, we reduce that down to just CaO. If any of this is unfamiliar, go back to chapter 3, please, and review it. And then we just have iron metal, which just means iron by itself. So this is the unbalanced chemical equation. Who do I want to balance last? Well, calcium or iron, because they're by themselves, which means that I want to first balance oxygen. So I've got 3 oxygens on the left. I have only 1 on the right. So let's put a 3 here. And that will fix oxygen. It messes up calcium, though. There's now 3 calciums. So I simply need to put a 3 in front of calcium. And that balances calciums. There are 2 irons on the left. So to get 2 irons on the right, we just put a 2 right there. And we are balanced. And one more question here. Again, you'll probably want to pause the video and write out the formulas as best you can. So carbon monoxide with oxygen produces carbon dioxide. Carbon monoxide would be CO. It's reacting with oxygen, which is O2. And it makes carbon dioxide. Okay, we've got carbon and oxygen to take care of. The carbon is initially balanced, but you see that we have an odd number of oxygens. So 1 plus 2 is 3. Over here we have 2. What we could do here is we need to get this to an even number, so anything times 2 will be even. Let's just put a 2 here. And so that would be 2 times 2 is 4 oxygens, and I bet if we put a 2 there, that resolves the problem. Indeed it does. 2 times 1, carbon, so we've got 2 carbons, 2 carbons. And then oxygens on the right, we have 2 times 2 is 4. On the left, we have 2 times 1 is 2 plus 2 is 4. So we are now balanced on those. I'm going to go ahead and end this video here. And when we come back, we'll start with the very important subject, the mole. Thank you.